We have made it to our final day of notes for Standard 5. In-class 23 is what you'll need today, and this in-class notes page will cover the last two types of proofs that you need to be prepared for when you take your Standard 5 assessment. So we've covered two proof types already, and there are two more with this notes addition, so that brings you up to 4 total that you're responsible for when we get to that Standard 5 assessment. Still a few days away. So what we're going to use today is a new idea about what we can do after we know that congruent triangles exist. So CPCTC is a big abbreviation. We'll talk about what it's an abbreviation for in just a minute. But the most important thing for us to know about it is that we can only use it after congruent triangles are known to exist, or in most cases, that means that you have proven that they exist. Okay? Only after. So it's never going to show up in the top section of a proof. It's always going to be either the last or second to last or towards the bottom of the proof after you've shown that there are congruent triangles available. So let's talk about what CPCTC stands for. The first C stands for the word corresponding. We used that all the way back in class 17 when we were talking about congruence statements, and we were talking about how that first letter corresponded to that first letter, or the first two letters when they form a side corresponds to the first two letters when they form a side. So that idea of corresponding is something we've already talked about. The P stands for parts. The parts are of congruent triangles, which is why we have to know that the triangles are congruent first before we're allowed to use this idea. So let's try to see if you can guess what the last C stands for. Corresponding parts of congruent triangles are something. So let's think. What's true about angle R and angle L? Or angle S and angle J? Or if we look at the third letters, angle T and angle M. I bet most of you have come up with it so far. They are congruent to each other. That's what we learned back when we started learning about congruent polygons. And so CPCTC is just an abbreviation for this phrase. Corresponding parts of congruent triangles are congruent to each other. It's kind of like you're using the definition of congruent triangles. We're just explaining that when the triangles are congruent, there are a whole bunch of other parts that will also be congruent. So I've already listed that there are corresponding angles that are congruent, but the other things that we could start listing would involve two letters and a segment bar above them, because we could also say that corresponding sides, segment RS is congruent to segment LJ. So we can use the idea of CPCTC for both showing corresponding angles and or corresponding sides are congruent to one another. So I have two more statements here about corresponding parts. I've used the first two letters to name a segment, so I need to use the next two letters. ST would correspond to JM. Both of those are segments. And then to find my final set, remember we're going to use the first and last letters put together. So we could do first followed by last. Segment RS is congruent to segment LM, or we could have said, oh, sorry, that should be RT. I said the wrong thing and wrote the wrong thing. So segment RT is congruent to segment LM, or we could flip it and say segment ML is congruent to segment TR. All 6 of these statements are true because of CPCTC. This abbreviation is listed on your assessment resource page, just like side, 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 side angle, side, and all the others are. So you don't have to memorize it. You just have to know when to use it and what it's useful for. So let's practice. right away, I'm hoping that you notice that something is true or different about this compared to all the other proofs we've written. Right here, there is a significant change. All of the proofs that we've looked at so far have not asked you to land on congruent sides. They've asked you to land on congruent triangles. And so this is our clue that there's going to be some CPCTC involved. We're going to have to find our congruent triangles, but then use them to say something else is true after. So CPCTC is going to happen after we find some congruent triangles. Okay? That means we're going to have to name the triangles ourselves. So I might just go ahead and make myself a note that we're going to have to name these. I can't fill this in yet because I don't have any congruent marks, but I'm going to search for some congruent triangles so that I can hopefully get to these corresponding parts that should be congruent. Okay, let's take a look at our first given. I'm going to write it down. O is the midpoint of segment MH. Write down right away. I knew that was true because it was given, but then head to the picture to figure out why that's useful. So if O is the midpoint of segment MH, that's the only part of the diagram I get to focus in on. Midpoints provide us with congruent segments. So directly after this idea is going to lead me here. Segment MO is going to be congruent to segment HO. That was true because I know what the word midpoint means. So definition of midpoint will be that reason. That's a pair of congruent sides, so I'm going to mark it with an S to keep track. I'm not ready for congruent triangles yet because I need more than one pair of congruent sides. So I've used my first given and I'm on to the next one. Angle N is congruent to angle Q. I am hopeful that when I go to my picture, angle N and angle Q, sure enough, are angles 1 in each triangle. So that information is good to go as is. I mark it with an A because it's a set of corresponding congruent angles, and I move on. Givens are used up, so I need to look in my diagram for one more piece of information to finish out what I need for congruent triangles. The two things I can notice from a diagram are that shared side reflexive property or vertical angles theorem. I see vertical angles right here in the middle. So vertical angles theorem will be my reason, and I need to carefully name those angles since there are going to be 3 letters involved. Angle MON is going to be my first angle's name. So then if I try to set up the other angle in a corresponding way, I would be traveling the green tick mark segment first. So that would look like angle HOQ. That would be a pair of angles. So I can tell I'm going to be making a decision between angle side angle and angle angle side. But because I was careful with how I matched up these letters in my vertical angles, I can use that same matchup in my triangle names. I'm pretty sure that I'm ready to say that triangle MON is congruent to triangle HOQ. I just need to make a decision between these two options. So if we look at that highlighted congruent side, is it connected to both of the congruent angles in that triangle or only one? It's definitely not connected to Q or to N, so this is going to be an angle side congruent triangle pair. Oh, before, our proof would have been done, would have been finished. But that wasn't the goal today. The goal today was to show that MN over here is congruent to HQ over there. If you look at your triangle names, does MN correspond to HQ? It sure does. So that means we're ready to wrap this one up. Segment MN is congruent to segment HQ because corresponding parts, that's what we checked for here, of congruent triangles are congruent. CPCTC, just so that you don't have to write all those words out. All right, we're going to have two more CPCTC, probably, proofs to take a look at on the back side. So go ahead and flip your page over and meet me back here for those two examples. All right, we are ready to go and to finish out these notes for Standard 5. Taking a look at this first problem on the left, the initial given piece of information involves that word bisect. So if I'm thinking about segment AC bisecting angle BAD, that is not going to be labeled with an S or an A yet because I don't see a congruent symbol if I'm just copying what was listed as the given. But if I investigate where all of those pieces intersect together, I'm thinking that the best thing to do next is to use that definition of angle bisector to talk about why that angle bisector is helpful. So again, this is leading me to a set of congruent sides or angles. And because I'm bisecting an angle, it should be a set of angles that I'm able to show are congruent thanks to that definition. Again, a single letter isn't going to work to name those because there are too many angle A's. So I'm going to call the one on the left angle BAC, and that's going to be congruent to angle DAC on the right. That can get an A now because it's a set of congruent angles. Okay, moving to my next given. It looks a little bit lengthy, so I'm going to copy it first. Angle BCA and angle DCA are right angles. Ooh, right angles are always a little tricky. So we're going to be really careful with these right angles. Sometimes right angles mean that we're investigating HL, hypotenuse leg, but other times right angles are used as a set of congruent angles. And we have to make sure we know which direction to go, because if there need to be congruent, I haven't said that yet, and we need to do that next. So let's go ahead and mark out angle BCA is right here, and angle DCA is right here. Now let's make the decision. Do we think this is going to be an HL proof, or do we need those right angles to be an A in one of our other reasons? This actually makes the decision for me. If I already have one pair of congruent angles, this is not going to be an HL proof because I wouldn't get to use those congruent angles if I were using hypotenuse leg. So that means I need these right angles to be another A. So that means I need to turn them into a set of congruent angles. Angle BCA needs to be congruent to angle DCA. That's true because they're both right angles. We have an official name for that called the right angles theorem that explains how if they're both right angles, they're both equal to 90, which means their measures are equal, which means they're congruent. So instead of having to explain all of that inside our proof, we can just use the right angles theorem to go directly from that given to that statement about congruent angles. So now I'm up to two pairs of congruent angles, and I've used up both of my givens. So moving ahead, I need to have some sides because there is not an option to have AAA, 3 angles. So I need a pair of sides somewhere. I'm pretty sure most of you have already spotted that we've got a reflexive property here in the middle. Segment CA in the left would match with segment CA in the right. C was the location of the right angle, so that corresponds. A is the location of those star angles. And that is our reflexive property again, helping us to use that shared side as a pair of congruent sides in these triangles. Now, just like on the front side, I'm being asked to prove something about congruent parts. But as soon as I have my 3 pairs of sides and angles, I need to make sure that first I show that there are some congruent triangles, and then this is going to happen because of CPCTC. So I need to carefully name these triangles. If I look at the way those right angles were named, BCA and DCA, they are perfectly set up to correspond. So I'm just going to steal those, but put a triangle symbol out front. Triangle BCA is congruent to triangle DCA. And if I have 2 A's and 1 S, it's time for me to make a decision between angle, angle, side, and angle, side, angle. Looking at that reflexive property shared side, that is connected to both the right angle and the star angle in both of my triangles. So this one is going to be an angle, side, angle situation. Now let's see if we can finish it out. Does BC correspond to DC? Sure does. So we're able to take our proof statement and fill it in. Segment BC is congruent to segment DC because corresponding parts of congruent triangles are congruent. CPCTC. All right, those both, so the example on the front and this example, were the same type of proof because we were given information, we proved our triangles were congruent, and then we said that there were some corresponding sides or corresponding angles that were congruent. This last example is the 4th type of proof. So there's something different about this one, and I think you'll be able to spot it if you look at the goal. Do you see how that proof statement involves a midpoint? Midpoints are vocabulary words. CPCTC does not tell us a vocabulary word exists. All CPCTC will tell us about is that there are some congruent corresponding parts. So let's imagine that we knew X was the midpoint of RT. Do you agree with me that that would mean RX and TX were the same size? So basically what we need to do is we need to get to the point where Rx is congruent to Tx. That's going to be a CPCTC step. And if we can get there, remember, after we get to some congruent triangles, then we're going to be able to make this statement about a midpoint and finish it all up. So we're doing a little bit of strategizing here. To get to a midpoint, we're going to need to get to these congruent segments, and to get to these congruent segments, unless they're just a given, which they don't look like they are, we're going to need to get to some congruent triangles first. So here we go. Angle Q is congruent to angle S. That's convenient. That's a pair of corresponding angles. So we're going to write it down, say that it was given to us, mark it with an A, move on. Segment XQ is congruent to segment XS. That's a pair of congruent sides. So we're going to write it down, say that it was given, and mark it with an S. I don't have enough for congruent triangles yet, and I've used up both of my givens. So this is where some vertical angles, it looks like this time, are going to help me out instead of reflexive property like the previous one. So I'm going to name those angles carefully. Angle QXR is how I'm going to name the one on the left, but you could have called it angle RXQ. That's going to be congruent to angle SXT. Those are the vertical angles, and we know they're congruent based on the vertical angles theorem. There's an A. Even though in my proof it looks like angle side angle, I know that I have to go back to the picture to make a decision about angle side angle versus angle angle side. So here's the side. Looks like it's connected to both angles in that triangle. Here's the side over here. Same thing, connected to both angles in that triangle. So this is going to be an angle side angle proof. Let's double check if these were set up correctly. I think I paid attention. Q corresponds to S, X corresponds to X, R corresponds to T. So if I change those angle symbols into triangles, that will work as a congruent statement for the two triangles. Again, angle side angle is what we use to show that those triangles were congruent. So we already thought about what we needed for X to be the midpoint of RT. Does RX correspond to TX? Sure does. So we're going to say next that segment RX is congruent to segment TX because corresponding parts of congruent triangles are congruent. And then if we were able to mark that, does it make sense now that we would be able to label this point, X, in the middle as the midpoint? If this side matches this side, then that's exactly what X is. So X is the midpoint of segment RT. We're just using the definition of midpoint backwards. Instead of being told there's a midpoint, we're noticing what's true, and we're stamping that vocabulary word on the situation on our own. So two different types of proofs. One, you'll say that there are some corresponding congruent parts. You might be asked to prove that angles are congruent. So instead of this segment statement, you might have been asked to show that angle B is congruent to angle D or something. That would still be CPCTC. But if you're asked to prove something about a vocabulary word, think about what would be required for that vocabulary word to exist, and then backtrack that to some triangles. CPCTC won't be at the end of your proof in that case. You'll follow it up with a definition. All right, that's the last of your Standard 5 notes. We'll see you back in class. Thanks for watching.